Hello everyone, my name is Jorge Isaac. In this video I will explain my project of a decimal to BCD counter using VHDL in quarters prime light, tested with the FPGA DA10 light board. The objective of this practice is to understand how to encode decimal inputs into binary code decimal BCD, which is used in digital electronics. Now let's see the design step by step. The first part is the VHDL or VHD. I create an entity called Dec2BCD with 3 signals, a 9-bit input called A, an enable signal N, and a 4-bit output X. So inside the architecture I used a process with a case statement. When the enable signal is set to 1, the program checks the value of A and assigns the correct BCD code for X. For example, if A is 0000010, the output becomes 0010. If the enable is 0 or other value is invalid, the output is 000. This is how the circuit ensures proper decimal to BCD conversion. So let's go to the test bench VHD. So here you can see the test bench simulates the input values for A from 1 to 9, both with the enabled signals set to 0 and 1. For each case, the outputs are observed. The result shows that when enable is 0, the output stays at 000. Sorry. When enable is 1, the outputs change according to the decimal input. This confirms that the design works correctly in the simulation in Cuesta. So let's go to the Cuesta view. Now here we can see the Cuesta simulation. So here you can see when the enable is 0, X will always be 0. But in the case our input is according to the output, only when enable is 1 will result in our output that we want. So this shows that the program works correctly. So let's go to the pin planner of the FPGA and how to upload it to the board. So this is the pin planner. Well, it's already here because I read it before, but the third part is the implementation. The inputs A were connected to the board switches and the output X were connected to the LEDs, LADs. The enable signal was also assigned to a switch, which this setup allows us to test the design directly on the DA10 light board, turning switches on and off and observing the corresponding BCD values on the LADS. So let's program the FPGA. You click on here and you click on start once you already connect the FPGA to your computer. So let's go to the FPGA and see how it works. So here we are on the board. All these switches represent the decimal numbers. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this switch represents the switch of enable. So when enable is off, it doesn't matter what input is on, it doesn't show us nothing. So let's turn on the enable and you can see the binary code in the FPGA. So here we have 2, 3, 4, 5, 6, 7, 8, and 9. So that's it. Thank you for watching, and in the next video of FPGA.